Modern-day passenger jets use a large amount of complex digital avionics that increase situational awareness and technical proficiency of their pilots. Here at CAU, we firmly believe that new pilots should be trained for the future and have a solid understanding of these complex systems long before they reach their final career goals. The term glass cockpit refers to the use of digital avionics instead of round gauges. All of our Cessna 172 SP training aircraft are equipped with the Garmin G1000 Nav3 glass cockpit displays. These two screens not only provide all the traditional data of older modeled gauges, but also have an abundance of additional features. The G1000 is divided into two types of displays, the PFD or primary flight display, and the MFD or multifunction display. On smaller aircraft, you will find one PFD and one MFD on the flight deck. On larger G1000 equipped planes, you will find two PFDs, one of which is located in front of both pilots, and one MFD located between the two pilots. The PFD contains all of your vital instruments for flight, including airspeed, altitude, attitude indicator, pitch and bank indicator, and horizontal situation indicator. We will look more in depth at these systems in a few moments. The MFD has many different functions. Aside from displaying all of your engine systems like fuel, oil, power, and temperature, the MFD also is customizable and has a moving map, trip planning, flight plan display, and much more. For this video lesson, we're going to focus on the primary flight display. The PFD, or primary flight display, is the screen directly in front of the pilot. In traditional planes using round gauges or steam gauges, each of these components are separated, which requires the pilot to scan a larger area, removing the time he spends looking outside of the plane. The PFD combines over 6 different gauges to allow pilots better situational awareness and more speed in time looking outside the aircraft. This improves safety through ease of use. On the left side of the screen, there are buttons and dials to change your navigation frequencies, course heading, altitude, and autopilot if equipped. On the right side, we have buttons and dials to change radio frequencies, altimeter settings, mouse functions, flight plan, and approach settings. Below the PFD are soft keys. These options above the keys change depending on the menus you have accessed. Let's take a look at the primary flight display. Look in the background and you'll see a large solid blue portion and a large solid brown portion separated by a white line. This is your artificial horizon. As we look out the front windshield of our plane, we can see the horizon. This is where the sky meets the ground as we're flying through the air. If for some reason we couldn't see outside, say because we are in a cloud, we still need to know what our plane is doing. The artificial horizon is constantly moving in the background during our flight. The blue represents the sky and the brown represents the ground, and the white line is where these two meet, which we call the surface. For simplicity, I have 2 traditional gauges to better isolate this feature. Let's take a look at the image on the left. As we pitch our nose down, we are seeing more ground. You will notice in the image, the ground has shifted above our yellow plane in the center of the screen, indicating that we are in a nose-down attitude. In this position, we would start descending. As we pitch the nose of our aircraft up, the blue portion would get bigger and the brown portion would get smaller, showing that we are looking more towards the sky. In the image on the right, you will notice that the plane is turning. When we bank to the left or right for a turn, the background moves also. If we bank to turn left, the background will move clockwise, showing more blue to the right and more ground to the left. If we were in a bank to the other direction, the opposite would happen. We would have more blue to the left and more brown to the right. By combining these two, we can tell both our point in which we are nose up or down and if we are banking left or right. As we just learned, the artificial horizon is in the background of the G1000. All of our other instruments are on top of this background. If we look to the center and upper portion of the PFD, we will find a group of vital information. With traditional gauges, This information is divided into the attitude indicator, slip and skid indicator, and or turn coordinator. Having all of this data displayed in one stop allows the pilots an ease of instrument flying and faster recognition of unusual attitudes. On the left image, this is what you will see on your G1000. The right image has all the parts labeled. Starting at the top, we have a rate of roll starting point, or 0, which is a downward triangle. This point does not move and shows when you are at 0 degrees of bank. Below that, you will see another triangle. This triangle moves as we bank to the left or right. Each of the tick marks along the half circle represent a degree of bank. Starting at the top, we have 10, 20, 30, 45, and 60 degrees of bank in each direction. Below the second triangle, you will see a small dash or trapezoid. This is our slip and skid indicator. During normal flight, we want this to remain under the bottom of the triangle even in a turn. We use our rudder pedals to move the dash. If the dash moves to the left of the triangle, we need to step on the left rudder pedal and vice versa for the opposite direction. You will often hear this referred to as step on the ball. This comes from traditional gauges where a ball takes the place of the dash. When the ball swung left, you step on the ball, meaning step on the left rudder. Moving down further, you will see horizontal lines with numbers next to them. Much like the hash marks on the half circle above, this indicates degrees. But instead of indicating degrees of bank of a turn, this indicates degrees of pitch. Pitch is the attitude of our plane, whether it's nose towards the sky or nose towards the ground. When we are climbing after takeoff or descending to land, amongst other things, we are looking for a specific pitch to get us where we want to go. As you can see, this small spot on the screen gives us a lot of information. Having it all in one spot instead of several different gauges allows pilots to quickly identify issues or verify their flight attitude. If you hear your instructor say, "Fly straight and level," they want you to have 0 degrees of bank and as close to 0 degrees of pitch without losing altitude, and the slip and skid indicator to be under the triangle. Next we are going to look at the airspeed indicator, altimeter, and vertical speed indicator. The left image is your airspeed indicator. This is located on the left side of your PFD. It is referred to as a tape instead of a gauge as it looks more like a measuring tape than a gauge. You will notice in the center of the tape it has a black box with the numbers 136 or 137 depending on who you ask. This is your current indicated airspeed. There are several different types of speed when we are flying, but the one we are most concerned with during flight is our indicated airspeed. Indicated means read directly from your tape or gauge. As we accelerate, the tape will move down so the numbers get bigger. If we slow down, the opposite. If you look just to the right of the tape, you will see a small pink or magenta line. This line extends up or down from the current airspeed and tells us what our airspeed will be in 6 seconds if our current plane's pitch, bank, and power remain the same. At the top of the airspeed tape, you will see a GS133. This is your ground speed. This tells you the speed at which your plane is traveling as if it were on the ground like a car. Due to winds when we are flying, our ground speed can be much lower or much higher than the indicated speed. If you have a really strong tailwind, it will push you faster through the air. Though our airspeed stays the same, we are moving faster across the ground. At the bottom of the tape, we see TAS140. This is our true airspeed. Our true airspeed is what we calculate to figure out how long it will take us to get from point to point. It takes things like winds, temperature, and more into account. Along with the magenta line to the right of the tape, you will see a green line and then a green with white line on the inside of the right tape. We have different colors from red, yellow, green, and white. Certain speed ranges are color-coded to quickly allow pilots to see the range in which they are flying without having to look at the specific number and remember. As your tape moves, these colored lines will change for the different ranges which our aircraft model is specific. On our G1000s, we have it configured to display small triangles next to important speeds. During takeoff, we need to reach a certain speed before we pick the nose of the plane off the ground, a certain speed to climb over an obstacle, or to gain the most altitude. If our engine fails, we need to know the speed that lets us fly the longest to navigate to the ground. Though not shown in this image, you will be trained on what these specific speeds are for your aircraft model. Now let's look at the image on the right. You will notice we have two different tapes. On the left tape, we have our altimeter. On the right, our vertical speed. Just like the airspeed tape, the current altitude is located in the black box in the center in which it displays 480. Just like the airspeed, these numbers get bigger from the top and smaller from the bottom. The box at the top of the altitude is referred to as the altitude bug. We set this bug for one of two reasons or both. When we take off, we have selected an altitude to climb to, or air traffic control has given us one. We put this altitude in the altitude bug so that when we come within 1,000 feet, we will get a chime to remind us. Next to the altitude that we bugged on the tape, a blue icon will display to let us quickly identify we have arrived at our altitude. For autopilot-equipped G1000 aircraft, your autopilot will remain this altitude once activated. Some additional features are available on your MFD once this is set. Below the altitude tape is our current barometric pressure setting. Here it is 29.92. Air traffic control will continuously update us on this setting. Ensuring it is correct is vital as your indicated altitude depends on this setting. To the right of the altimeter we have the vertical speed indicator. This tells us how fast we are ascending or descending in feet per minute. The current vertical speed is once again located in the black box. However, this black box moves up if we are ascending and down if we are descending. The big numbers 1 and 2 represent 1 and 2,000 feet per minute respectively. The last big item we are going to discuss is the HSI or Horizontal Situation Indicator. The name sounds confusing, however using this data, you can navigate the skies and or find your way when you are lost. The first thing you will notice is the round dial with numbers. Starting at north and moving clockwise, it indicates cardinal directions in 30-degree increments. At the top of the dial, you will see a small white triangle. This indicates the current heading or degree your plane is flying. Unlike cars, however, planes may be facing one direction, but due to strong winds, they are actually tracking across the ground in a different direction. For this, we need to know what our ground track is. Next to the triangle in the picture above is a magenta diamond. In the example on the left, our HSI says our plane is flying 360, both noted by the triangle and the black box above it. The magenta diamond says we are actually tracking 5 degrees to the right as if we were on the ground. If we made a flight plan, and at our current position it says that we need to be flying at 5 degrees on the compass, we would make sure that our magenta diamond is over the 5 degrees and find out what heading we need to fly in order to make sure that we stay at 5 degrees. Here, we would be flying at 5 degrees, but our aircraft would need to maintain a heading of 360. In the black box at the top left, we see HDG 360. This is what we have our heading bug set to. We use the heading dial to change this, and as we select the heading we want, a blue icon on the HSI will move to that heading. This helps us have an easy way to ensure that we are flying the heading we want or remember a heading to turn to when doing a procedure. Additionally, if our plane has autopilot, our plane will maintain this heading once it is set and activated. During your flight training, you will learn how to navigate using both GPS and VOR. VOR uses a radio frequency from a station on the ground. On the left image, we see green needles, and on the right, a magenta. Using the CDI button below the HSI, we can change between GPS and VOR modes. You will learn more about this during your flight training. The black box at the top right, which says CRS 160, is the setting for either of these navigational aids. The last part we are going to talk about for the HSI are the 4 hash marks at the top of the dial on either side of the current heading. As we turn, a magenta arc will appear. As we increase our rate of turn or rate of roll, the arc will get bigger, extending down either side. This allows us to know the rate at which we are turning. A standard turn is 3 degrees per second, which means that we can make a 180-degree turn in 30 seconds or a complete 360 turn in 1 minute. The second hash mark is a standard turn. As we turn, the arc will extend to this mark if we are making a standard rate turn. For the half standard rate turn, or 1.5 degrees a second, we only want the arc to touch the first hash mark. There are a few more functions of the HSI that you will learn throughout your training as you progress through your certificates and ratings. If you are a pilot who will be using the G1000 or will start flight training soon with the G1000, you will need to learn all of the hardware components to the G1000. This is vital in the case of failure of one or more systems. Learning these components will allow you to problem solve and knowing which instruments will be affected in event of a failure. This diagram is directly from Garmin and is published for pilots like yourself to know the breakdown of the G1000. A link to this diagram is in the description. This concludes the overview of the G1000 and the primary flight display. Whether you will be starting your flight training at CAU in the near future, or looking to rent a plane that is G1000 equipped, you will have extensive training and familiarization flights using the G1000. This short video should not be used as a training aid, but rather a brief introduction to the G1000 NAV3 glass cockpit. We are certain that you will love flying with the G1000 and learning all of its features. If you would like to learn more about the actual user training, please give a visit to the links in the description section of this video. We will provide direct links to the G1000 training video, the G1000 Pilot's Guide, and the G1000 Cockpit Guide. Looking to challenge yourself? See if you can find the answers to these 4 questions. Give us a like and a comment below with your answers. We will pin the person with all 4 questions correctly answered to the top. If you will be using the G1000 on a check ride, you can believe that these questions will appear from your designated pilot examiner. This concludes the lesson on the G1000 and primary flight display. Take a look at the description for a couple links for additional training aids. We hope you enjoyed, and we look forward to your flight training at CAU in the near future.